So our theme for this session is localizing precision agriculture. We have two exciting topics lined up that will showcase innovative technologies transforming agriculture in the Philippines. Our first topic is revolutionizing pineapple farming, integrating drone mapping platforms with multispectral sensors, GIS, and remote sensing. We are honored to have John Mark Manhuyod from Del Monte Philippines Incorporated to lead this session. He is a devoted husband and father of two wonderful kids. Beyond his familial roles, his passions extend to the world of freshwater fishes, chess, piano, and a deep appreciation for music. But above all, he's a follower and a servant of Jesus Christ. Professionally, he is an agricultural engineer, having earned his degree from Western Mindanao State University in Zamboanga City. Currently, he serves as the supervisor of the Geomatics Department at Del Monte, Philippines. In Manolo Fortich Bukidnon, and this role he has held for nearly 8 years. So a warm of applause, please, for Sir John Mark Manhuyod.
Thank you very much, sir. Good afternoon, mayang hapon sa mga Bisaya, and magandang hapon sa lahat. Okay, welcome to my session this afternoon, revolutionizing pineapple farming, integrating drone with multispectral sensor, GIS, and remote sensing. Again, I am John Mark, and I'm from the province of Bukidnon, employed again as a geomatic supervisor of the Monte, Philippines plantation. So our company has been 98 years already, and 2 years from now, we will be celebrating our first centennial anniversary. Okay? Yes, our company is old, but we are not stuck. Okay? So we're moving forward, and that's where innovation comes in. Okay, so by using these drones, all these technologies, okay, so we are actually moving forward, and it's really challenging to also convince or even influence our people, our old people there in the plantation to also adopt these technologies. Okay, so can next slide please. Okay. Our plantation is actually located in the northern part of Mindanao in Bukidnon, Region 10, and we're covering about 13 municipalities all throughout the province of Bukidnon and Misamis Oriental. Our estimated total farmland is actually 23,000 hectares. And ladies and gentlemen, we do not follow season. We grow pineapples every day, we plant every day, and we harvest every day. So before being assigned in the geomatics, I was in the operations. I was in charge in handling 600 hectares of pineapple fields. So to support our production, it is really important for us to adapt these new technologies like the drones, the GIS, and remote sensing. But let's be honest, it's really hard to select which of these technologies that we will gonna use. There are lots of technologies or this GIS and remote sensing na general knowledge lang, but to customize it and to use it in your own farm is really, really challenging. But by God's grace, we have developed it since 2015, and I was part of the trailblazing. Now, next slide. Okay, BMPI has acquired its own drones since 2015. We have started with these European drones called the AB. We have actually purchased these EB fixed wing drones. Next, please. Again. Okay, so since 2015, and however, since 2021, we have transitioned already to using multi-rotor drones from Davao UAS. Why? Why did we shift? Because this Davao UAS, this local supplier, provides reliable maintenance program. And mas mura yung mga drones nila. Mind you guys, if you are trying or planning to buy drones, be sure that your supplier can provide that maintenance program. That's one of the main key. Next. We have also acquired several multispectral sensors. Again, we're not just trying to fly toys in the air. We're actually acquiring valuable data using multispectral sensors and RGB sensors. Flying drones is one thing, but processing the images and analyzing the images is a different animal. Okay, these two tasks are quite different and requires distinct skills. Now, we're using our multispectral sensors because it provides those bands which cannot be seen by our human naked eye, such as the red edge band and the NIR, which we use in assessing our crop health. Now, choosing the right sensor for our purposes is also critical. Factors influencing our choice of that kind of sensor depends on the type of data we require, the specific agricultural needs of our pineapple, the resolution or the ground sampling distance that we need, the cost of that drone, the budget of our management, and the maintenance program that this supplier is providing. Okay, those are the things that we consider in selecting the sensors. Next slide, please. Now, the average covered net planted area of our drone mission every year is 28,000. I'm just talking about the planted area. So if I multiply that, no, if I compute for the total flight coverage of our drone in a year, we're about actually covering 44,000 hectares per year. Ibig sabihin, we fly our drones also every day. So 29% of our flights are used for crop health monitoring, 22% for the crop health monitoring for the fruiting stage, and 33% for the topographic mapping and other special additional flight requests from our internal customers, and 16% for field digitization. Okay, so we have several flight mission challenges. Okay, one of these challenges is actually yung ulan, rain. Our average rainfall in Bukidnon is actually 2,800 millimeters per year. And just like 2022, it was the highest. We reached up actually about 3,400 millimeter on that year alone. So it was really challenging to fly our drones because we only have at least 4 hours average to fly our drones. Okay, and even if the sky is clear, but the wind speed is so high, or it goes higher than 8 meters per second, then we cannot fly our drone. Okay, not to mention also our other challenges in flying on drones, such as the steep terrains, the dilapidated and slippery clay roads, and the non-contiguous or sporadic fields that we have. Okay, our drone controllers are not just skilled in operating our drones, but they are also skilled in maneuvering their pickups and going to these fields. Okay, and yes, the navigating to these fields is really quite challenging. Now, again, we fly our drones every day. Next slide, please. In a day in a life of a drone controller, they perform this general drone mission workflow, which I'm sharing to you here, starting from the pre-mission procedures, then to the field arrival and pre-launching activities. Then they launch their drone, the drone will fly, and after that, they will perform these post-flight and landing activities. Then they will travel to another field for their additional flights, and after all the targets are completed in a day, they do these post-mission procedures. Now, we have our daily, weekly, monthly, and yearly drone flight targets. And every day we record our accomplishments. Okay? We provide daily report and we provide weekly report, and we analyze the utilization of the drone. Ibig sabihin, we record the drone operators reports at 4:30 a.m. in the morning, and they have to fly the drone at exactly 6 a.m. in the morning. Okay, our drone operators, okay, after the targets are accomplished within the day, the team goes back to the office and perform post-mission procedure and actually processing the data. Next slide, please. Okay, since we want our drone operations to be efficient and productive, again, we monitor and analyze our drone utilization. We have developed in-house, kami na develop ito sa team namin, okay, and had a customized digital drone checklist and data logging using our smartphones. Aside from recording the drone launching and the landing time, we record the time that these pilots or controllers depart from the office. We also record the time they arrive on each field, and what time they depart from each field. We also record all the schedule and the unscheduled downtime. Ibig sabihin lahat nakalag for us to properly monitor the utilization of our drones. Next slide. Now I am going to share to you some of our drone data products that we have developed in-house. Next slide. Okay, this is a pineapple field image. Okay, so as you can see here, this is an RGB image of a pineapple field. And then you can see here, this is just a newly planted field. You can see the block. This is the block. These are the rows. We have the canals and we have the roads. Okay, so one of our main data product is the production of digitized field maps, which is primarily used by our operations and all the departments of our plantation. On the screen again, you can see the RGB image. Next slide. Now, from that RGB image using supervised classification in a particular software, we can also use QGIS or rendering Envy, okay? We can actually digitize all of them using the spectral signature. You classify the pixels, and then from this, we digitize them, and we identify which of these pixels are for the pineapple plants, for the roads, and for the canals or ditches. Okay, so next slide. So this is one of our final map from that digitized image. Okay, we form our official map. This is just an example where we provide a lot of information. Actually, compared to the conventional map that we had, we have developed or produced 28 more information that we have added on this map of our new drone-based map. Next, since we can digitize our fields, we have consolidated all of them and created our plantation maps. So siguro masyadong maliit na to, but they are distributed again to 30 municipalities all throughout the 2 provinces. So if we will zoom this, ganito yung magiging itsura niya. They're all digitized. Okay? So we have actually digitized 100% of our 23,000 pineapple fields at block level. So every year, we update them. Okay, ibig sabihin yan, at least we have polygonized or digitized 23,000 blocks already. Next slide. Okay. So another data product that we provide is a 3D visualization of areas under land preparation. So sorry, supposed to be gagalaw-galaw to, pero hindi na gumagalaw. So and we use that actually in assessing our new lands for pineapples. We also use our 3D in designing our drainages, even our soil erosion controls, and even in designing our field roads and blocks. Next, aside from this, we also produce our other topographic maps, which we include already the ortho maps, next, the elevation map, next, the slope map, and next, the contour map. All of these are being used by our operations people on the ground who are in charge in growing their pineapple, and especially our people from the land preparation, and even in our department, which is assigned also in designing the drainages. Next slide. We also produce this field hydrology map from the DTM, the digital terrain model, or the digital surface model of a field. Without those pineapples, we produce the hydrology maps, which we are actually using QGIS and SWAT, the soil water analysis tool, to generate all of these channel streams and the sub-bases of the watersheds. These are very, very important in the design of our drainages, such as for us to compute for the runoff coefficient and also for the hydraulic design of our ditches. So yun yung mga use nila. Next. We're also using this flow direction map. In each color, makikita nyo dito where the surface runoff would flow. Aside from the arrows, these colors would represent the flow of the direction of the flow of this surface runoff. Some people on the ground cannot have this hard time on reading contour maps. So we're just providing this for them to better understand the flow of water on the ground. Okay, next slide. Okay, pineapples are almost hydrophobic. Hindi nila kailangan ng tubig. So they hate water because of these waterborne diseases. So we have to remove these low spots on our pineapple field during land preparation. So again, using the DTM or the DSMs of bare land, we scout these low spots in the image and provide field low spot maps to the operations people as their reference in leveling lands before planting. So in this example, we took an image of this pineapple field here, and I was the one who ground truthed this. I got a 97% accuracy for this, and then we provided this to the operations, and then they did this leveling, and after leveling from 7% low spot, it went down to 0.5%. Next, we also have this temporary soil erosion control structure, which we call check dam. Okay, so we install them right before planting to control the soil erosion and maintain the flatland slope. Now, using again the DTM from our drone, the digital terrain model, we generate the slope map. And from the slope map, we also overlay our vector data of our canals, and we get the average slope of a canal. And based from that, we can compute for the spacing of our check dams. Since we can compute for the spacing of our check dams, we can also compute for the number of check dams that we need for a particular location. That means that we can plan and manage the cost of the installation of our check dams. Next, we also produce our vegetation in this index maps. There are lots of vegetation index, and one of the vegetation index that we're using is the NDRE, or the normalized difference red edge. We're using the NIR band and the red edge band. Okay, so we generate VI maps. Okay, so in this example, okay, you can see there we divide the pixels into three strata: the red, the yellow, and the green. Okay, so there the red represents the relatively poor areas. The yellow represents the relatively average areas, and then the green represents the relatively good areas. We also did our ground truthing, and we found out that that's on this image, the red represents those areas which are not growing properly because they have root problems, because they were infested with this white grub insect. Okay. Next, the yellow ones are here. They're not that tall, and the green ones, okay, they have higher. They're more greener. They have higher nitrogen indices. Okay, so we found out that this kind of map is very useful for our operations people, because it's really challenging for them, because one area supervisor has an assignment of 300 hectares. So he has to monitor all of that. And without this tool, it would be difficult for him to monitor. Okay, next. We also have developed our plant counting algorithm, and we produce this plant count map. Using high resolution image at 3 centimeters per pixel, we have developed and optimized a technique for plant counting. This is so critical in maintaining the density required per hectare and in setting up the yield in metric tons per hectare and achieving the yield commitment per field. So we got about 94.5% accuracy for this. Next. Okay, using the same data set, we also can assess the crop health of the plants individually. So ibig sabihin nito, yung mga pula represents those plants which have poor root health. Okay, the green ones ay may medyo healthy. So as you can see here, it's a typical example that there is a low spot problem here before, and they found out that because of this image, meron nakita niyo dito, okay, these ones here have problems in water, So they put another canal just to remove the excess water. So by this image also, we can actually compute for how many plants which needs to be replanted or replaced. They have to be replaced as soon as possible. Okay. Next slide. We have also developed our field weed maps. We can actually quantify the coverage, the area coverage of our weeds, but we still cannot identify the species. It would be very hard. Even if I think if we would gonna use the hyperspectral, it would need a lot of storage, processing. Okay, but I hope we can go to that. But right now, this is what we can do with our multispectral camera. This one here is actually a pineapple, and these yellows here are actually the weeds covering the pineapple, and we've classified them, and after classifying, we digitize them and quantify those red pixels, and we've estimated the hectareage of those red pixels, which is in this case, it's about 1.95 hectares, or about, they're covering about 9.57% of the area. Now it's also a challenge to fully operationalize this program as it requires tremendous budget allocation for drone system. Okay, marami kailangan sa manpower requirement, and even the data storage and even the logistics, even if we want to cover half of the 23,000 hectares. Okay, now, we also produce have this GIS and remote sensing data. Next slide, please. Okay, next slide. With our GIS and remote sensing, we produce our pineapple suitability maps. Not just actually pineapple, we're also going to other crops also that we can also use for our areas which are not planted by pineapples. Okay, we are actually using a lot of criteria such as the elevation, slope, land use, soil type, soil pH, temperature, and others. Next slide. We have also generated the major watersheds maps where our pineapple fields are located. So we have actually covering this 6 major watersheds in the northern Bukidnon. Next slide. We're also into GEE already, the Google Earth Engine. We're also using that for our crop health monitoring as a supplement, that we should complement our drone images. For next slide. We're also using the Google Earth Engine during our during the drought, okay, for monitoring which of the pineapple fields were badly heated. But we're badly hit because of this El Nino. Okay, so next slide. We're also using the GE for our forest fire monitoring. We help our LGU in monitoring the forest fires within the area where the pineapple plantation is located. Okay. And next slide. Okay. Now, since our pineapple fields are sporadically distributed throughout the provinces of Bukidnon and Misamis Oriental, it is very challenging to memorize and even navigate to these fields. That is why I have developed our mobile digital maps and using this QField, which is an open source software, okay, as our tool. This has been very helpful to our equipment operators and to all operations and support departments para hindi mawala sa field. Okay, they're using that. Okay, last slide. So my team and I have developed also an online portal where our internal customers can request maps and data online. Okay, these customers can also monitor the progress of their maps, and using this online this portal, we can actually provide them the finished map. Okay, using that online portal. Even us in our department, we can actually monitor. We can actually assign the task who will do it, and we can monitor the progress of these maps. Okay, so as you know, we need to deliver the maps while they are still relevant. It is so crucial to provide them when they are most needed, rather than when their usefulness has diminished. Again, that would be my presentation for this afternoon, and thank you.
A round of applause, please, for Sir John Mark. So we now open the floor to any question that you might have for our speaker. So who wants to go first? All right.
So, of course, yung the Monte is a business entity, no? So, I guess meron na kayong hostage per hectare, no?
Yes.
And how much kaya yung naabot ng kasama na yung maintenance, pati other overheads,
Okay.
pag-operate ng
Ang ganda ng tanong mo. Okay, thank you for that, sir. Okay. You're asking actually the cost per hectare. Now, may iba't ibang cost per hectare depende sa data product. Depende rin sa drone na gamit mo. So iba-iba. Should I divulge? Okay. The cost. Range lang, range. Okay. It can be 200 to 800, even to 1,000. Depende sa application. Before we hire these drone suppliers, gasto namin sa kanila from 700 to 1,000 pesos per hectare. But because of this in-house, we've reduced it significantly. We actually even got to 200 pesos per hectare.
All right.
Yeah, thank you very much, Joseph. That's very insightful presentation. Still related to the cost, yung tatanong ko sa'yo. Since meron kayo sariling drone, and I think you're the best person to answer this. Ano yung ROI ng pag-invest sa drone?
Okay,
Overall operation.
thank you po. Thank you for the question. We have also computed ROI for each for each application. Okay. I think yung sinasabi na naman namin dito sa iba, for example, sa field digitization lang. But the first year, masasabi namin saving siya kasi it's still happening. No? We've actually, the gross was 8 million pesos per year for that one application alone. And every year after that, hindi na namin masasabing savings but cost avoidance na lang. We've actually avoided about 8 to 10 million. That's the gross, still the gross, without actually deducting the cost of the operation of the drone. That's for one application lang po. And others, percent. Actually, wala akong idea sa finance namin, but we're actually, sa part lang po namin, we're actually computing for this application was the savings and all of that. And the total, actually, since we have started 2018, nagsimula kami 2015, but they were all just trials, and nag-operationalize kami 2018. And we have actually saved up even more than 50 million already. All right, cannot just give you, hindi ko lang alam for yung percentage na po.
All right. Last question for this topic. I think she raised her hand first.
Hello sir, magandang hapon.
Ganda nga po.
Paano po ninyo ginagawa yung pag-digitize ng fields? Gumagamit po ba kayo ng software?
Yes.
Okay.
Okay.
Ano pong software?
Ano pong software? Sige. Nandiyan naman si Engr, si QGIS, ayan, gumagamit din kami ni AutoCAD, sorry, hindi ako magamit ng ARC. Medyo mahikama. Ano kaya siya we paying that we opt to pay na lang sa mga image software, image classifying software po. So, doon na lang po. Paano namin digitize? So, semi-automatic, merong automatic, pero minsan manual po.
Okay, so combine.
Depende sa class quality ng image. Okay, thank you.
All right. So thank you for the engaging questions and discussions. Once again, a round of applause to Sir John Mark. And then moving on to our next topic, we have drones for rice, development of standard drone application protocols for rice production systems in the Philippines. We are pleased to welcome Engineer Joseph Sandro from IRRI. He's an expert in agricultural mechanization, post-harvest, precision agriculture, and agronomy. He also obtained his bachelor's degree in agricultural engineering from the University of the Philippines at Los Baños and is currently getting a master's degree in agricultural engineering in the same university. Engineer Sandro will present the development and implementation of standard drone application protocols designed specifically for rice production systems in the Philippines. And after his presentation, a usual Q&A will follow. A round of applause, please, for Engineer Joseph Sandro.
Thank you, Jero, and kay Bayaw
John Mark, no, for making an introduction for my talk. So basically, most of the technical details about drone was already presented by Engineer Mark. And what I will be presenting today is basically I will give you the overview of how at IRRI how we are using drones for rice research and our recently launched project funded by the Philippine government on drones for rice. Next slide. So basically at IRRI, to give you just a quick glimpse of what we are doing for with the use of drone, we are, I think as far as I remember, it's more than 10 years already that we started, since we started using drones for rice research, basically for phenotyping. And then today I will be focusing more on the use of drones in agronomy, crop management, and scouting. So firstly, in nutrient management or in determining the status of the crop based on its appearance on the images. For example, we are here at IRRI, we are using the multi-spec camera, or which is our drones are equipped. So previously, like what Joe Mark has shown, we have a drone and a separate camera. But right now, the technology is quickly advancing. We can now buy a drone with this multi-spec camera. So, and then the price is somehow reasonable because yung multi-spec camera is almost the same as the price of the drone before. Yung pinakita ni Engineer Mark's plate kanina. So next will be on weight management. So here, for example, we can use thresholding technique like the UTSO, or ano ba term? UTSO is a method that we use for determining, or parang automatic niya na sineseparate yung foreground at yung background. So for this example, we have this image of the crops or of the plant with a RGB camera, and then with this automatic technique, which is UTSO, isi-separate nga yung foreground and background. So dito mag-a-appear na yung yellow or the weeds. And we can also do some advanced machine learning technique and ma-identify na yung mga weeds. Pero so far, mag-start pa lang kami sa ganitong research dito sa IRRI. Yung nabanggit din ni Engineer Mark kanina, yung determining talaga ano yung species ng crop, species ng weeds. Next is ito. Next is we can use the drone to create the DSM, or the digital surface model. So with just a simple drone, actually yung mga mumurahing drone na RGB camera lang gamit, we can use that for this technique. You just need to have an access to another software that will process your data. So for this example, we have a plot. Makikita nyo, ang kanyang classification is 5 centimeters. So this area is a low spot area, and then somehow this field are level, but still it's not well leveled. And then with that information, we can use the laser leveling much better, or kung wala yung farmer, the traditional leveling using board or tractor. So for this, balik dun sa una, i-emphasize ko lang for laser leveling, for leveling, we just need the common camera that you can access. Ang pinakamura as far as I know is yung maliliit na 5,000. You can buy that RGB camera, and then you can use that already. So it's not, hindi siya kailangan maging mahal. So isa din yun sa gusto namin emphasize dito sa project. So next will be yung detection of disease. So yan, with the usual RGB camera also, ito yung image na makikita mo. By visual inspection, you can already determine kung ano yung mga damages. But with multispectral camera, ito yung image na makikita natin. So makikita mo kung saan yung mga spots and anong plots talaga yung affected ng bacterial blight for this example. And this one naman, ito yung image using thermal camera. We both have these drones na equipped with thermal and multi-spec. So with all those information, we can actually create what we call prescription map. And with this, for example, we have the data or the image from an RGB camera, and then with machine learning, it can classify which are the rice, the wheats, and which are water. And then you can input that data on the drone software. So what we have right now is an XAG drone, which we can do this. So this is the actual screen grab picture from the XAG app that is available in, mas gamit namin siya on Android, but later, as far as I know, i-release nila yung much better version for iOS. So for this example, we can actually vary the amount of application to be applied in a certain plant. So may savings yung farmer. So hindi niya i-complete isang rate lang yung buong area. So that's the goal of having a prescriptive map. Next is the use of drone for, we can also classify. In other countries, we have projects that we need to classify if the plants are transplanted, line seeded, or broadcasted. So we can easily do that using the drone images from our drones. Next will be identifying which farm or farmers are using AWD or alternate wetting and drying. So in other countries, also in the Philippines right now, nagkakaroon na tayo ng mga companies that are crediting the carbon carbon credits if farmers are practicing, for example, the AWD. So in the ground, you can use this tool, but actually, if we have a very huge area, we need a sufficient. So that's why drones can be used for MRB or monitoring. Recording and verifications. So for you, if the normal or the inexpensive or not expensive drone, you can use the RGB. So the technique is just to put a base on the side and a floater, which will float depending on the amount of water it will. And then you do the DSM or the direct or the surface model. And if you have a much more advanced drone with a thermal camera, we can do this technique. Okay, so ito yung image na makukuha ng mga thermal drone. And then makikita nyo alin yung mga spots. For example, kapag black, those are flooded fields. Actually, makikita rin natin dito. For example, this field, this is one field. This is not properly well leveled. This is not well leveled. So mataas dito, mababa doon, kaya flooded. So next will be, with all this, so far, ito yung mga drones that we have here at IRRI. So we started with the fixed wing, the EV, and then after we retired this, we have this multi-rotor, and then we shifted now to the new ones, which is the Mavic multi-spec and thermal. So for spraying, previously we have the DJI, and right now we have this also, the XAG drones. So what are the requirements or the specifications that we are looking for those? For example, for this one, for bigger drones or agricultural drones, we want it to be fully autonomous. So this drones is fully autonomous. You just put your flight plan on the app, press the button, and it will spray or spread the material, and it will return to the return home after finishing the flight plan. So it also covers a lot more capacity compared to the previous drones. And then in terms of sensor, these are the sensors that are in the drones that we are currently using. And it can go for a resolution of 1 to 10 centimeter per pixel. So it depends on the requirement. If you go lower, let's say 1 centimeter, the drawback will be the capacity of the images. So you have more pictures that you need to store. Next, with this capacity, Philippine government funded a project, what we call the Drones for Rice, or mahaba kasi yung mahaba yung buong title. And the main rationale of this is next slide. So modernization of agriculture and agribusiness is one of the key transformation strategies in the Philippine Development Plan, yung pinalabas ni through nitong time ni President Marcos. So farmers must improve their productivity and reduce the production cost. One main objective. Drone technologies are ideally suited for bringing the benefits of precision agriculture to smallholder farmers. And it also reduces drones are readily available in the Philippines, but regulations for their use are in place, but additional work are still needed to reduce the regulatory constraint and standard operations. And work is still needed to better understand the socioeconomic and behavioral aspects influencing the adoption, because we want to really make our farmers to adopt this kind of technology. And it's also followed the 4 pillars, next slide, of the 4 core strategies of the Masagana Rice Industry Development Plan. So most commonly called the Matatag, Sama-sama, Ganado, and Napapanahon. Okay, so the project is next, led by IRRI and PhilRice, and with all our collaborating government agencies and also private sectors. So we are fortunate today that we have the Agridom as our partner, who is attending also this workshop, or the ICTforAg. So our target benefits, of course, are farmers, our Philippine Research and Development and Extension agencies, the farm service providers and entrepreneurs, and of course our government and policymakers. So the target sites that was identified under this project are 3 regions: Region 2, Region 4A, and Region 5. But with the program of the government, the voucher program, I think we will be not covering, but somehow mag-i-input din doon sa iba pang regions, or yung mga data nila will be shared, or yung result dito will be shared to other regions. So the project I proposed for 30 months or 2.5 years. So the main objective basically is to contribute to the improvement and productivity, competitiveness, and income of smallholder rice farmers through adoption of drone-based precision farming technologies. So specifically, we aim to develop standard protocols for application or uniform drone application of seeds, fertilizers, pesticides, and other input. And we also aim to develop the drone-based crop monitoring protocol for mapping nutrient status and mapping the weeds. And with that, we aim to develop a drone-based VRA or wala tuloy yung ibig sabihin. Variable rate application protocol for mid-season nutrient management and weed management. And lastly, we will scale and develop the sustainable drone-based precision farming technologies for our farmers. With the project is divided into 3 work packages. So that's how we design mostly our projects here at IRRI. So work package 1 will deal with next slide. Direct wet seeded rice and precision nutrient management. Okay, and then basically all the activities of that work package are here. And then work package 2 will focus more on the pesticide, on precision pest and disease management. And then the work package 3 will focus on the scaling and sustainability of this project. So for the outcomes and impact, these are what we perceive to improve the rice-based standards, regulatory policies, and agency coordination. So right now kasi for drones, we have CAAB, and then CAAB. And then for the input, we have FPA. So all of these actors, we need to bring them together and decide and talk and whatever. Marami pang challenges na nakalatag para sa amin. So next, we aim to improve the site-specific crop nutrient and pest and disease management at farm and regional levels. And lastly, increase the adoption of drone technologies and precision agriculture by partners and service providers and farmers. So in the Philippines, if you want to be a service provider for drone, you have a lot of how many certificates or certification? 5, I think. 5. So it's very difficult for them. And we only have 2 service providers registered right now. So that's the struggles. And for the impact, so of course we want to increase the income of the farmers, resulting from high productivity and lowering their production costs. Ito hindi masyadong obvious, pero if we apply the precision farming techniques, actually, we are reducing the carbon footprint of our rice production because we make the activities more efficient. Improve the farm safety of our farmers in handling and in use of fertilizer and pesticides by having the standard or clear standard protocol for each application, and to modernize our rice farm or rice farming systems in the Philippines. Okay, with that, I hope that I give you a clear or picture of about our drone for rice project. So ito pala, yung mga picture ko pala na pinakapakita dito, just also to promote probably because we are ICT. Ayan ay na-generate ng mga AI software. So Copilot, I'm using Copilot. So you just ask the Copilot to draw or give you an icon representing these items. And yan yung binigay niya sa akin. Diba? Parang I want, sabi ko, give me an icon showing an increased income, reduced carbon footprint, and so on. So it's an AI. Any question?
All right, so thank you, Engineer Sandro, for that fascinating presentation. A round of applause, please, for our engineer here. So we now invite any questions from yes. Mabilis.
Thank you, sir, for that very interesting presentation. My first, sir, okay. My first question is, in terms of like altitude, ano po yung optimum na ginagamit niyo for crop monitoring and pest monitoring? And my second question is, sa pest monitoring naman, sir, di ba meron akong ano yung sa blight, so sa disease, ano, so have you tried developing protocols for insect pests? Thank you.
Actually, that will be the output of this project, the protocol. Anyway, for the first question, what we are, it depends on it depends on the purpose of your flight. For example, as you said, monitoring of ano yun? Nutrient. Yung mga bagong drone, ang nakalagay na ngayon is GSD, ground surface distance, sampling distance, ground sampling distance. So, pwede mong iset kung 1 cm up to 10 cm, 5 cm. So, kami ang ginagamit namin 1.5 cm. So, that's around 32 meters ang height. So, enough na yon for ano. Yung mga older drones, ang sineset mo is yung height mismo, yung altitude. So, dati ang ginagamit namin is sa monitoring is around 30 meters. So, roughly 1.2 centimeter yung per pixel yung resolution.
All right, so we have another question here.
Meron din on.
So, I haven't introduced myself. I'm engineer Dan from Spectrum, private company. Ask ko lang if ano ba yung plans to reach out those farmers from far-flung areas, no, which are very vulnerable for pests, infestation. Then actually yun pest is very time essential na pagdating to may presence na ng pests, then we should act on it na, di ba? Kasi imbis na lumala, we can cut off the infestation to reduce yung significant losses or economic losses. How do we reach out to those parang hindi siya kanila accessible yung internet? How do we do that?
May taga-DA pa dito. So, sa research kasi, we are focused on the science. But of course, as part of our project, we have the scalability and sustainability. So that's why we are partnering for all the agencies under DA, which are tasked or ito yung main responsibilities nila. So our main role is to do the science and then somehow capacity building, equip them if they need the assistance from us. And then yung operations sa na yun talaga. Sa mga regional centers natin, regional crop protection centers, we have all those agencies. Yun.
Thank you, engineer. So,
Siguro idagdag ko lang, para lang din sa kaalaman ng lahat, yung drone hindi pa niya kayang i-forecast up. Hindi pa niya kayang forecast kung magkakaroon ng pest infestation. Tingin ko. What we can do is yung damage na lang, assessment. Yun yung ginagamit ng drone sa assessment. So kung mapipredict mo, sasabihin mo or itatanong mo, kaya na ba ng drone na i-predict meron ditong possible leaf blight or bacteria. But we can do the assumptions kasi mabubuhay ang mga yon kapag ang condition is present, yung mga let's for example, yung mga blight. So kapag kayong condition na conducive dun sa mga bacteria or sa mga insect na nagdadala nun, so pwede mong i-assume yun, pero hindi talaga kayang i-forecast.
Kasi parang kasama ko siya dun sa parang goal din is to monitor, no? So, pag monitoring, parang in a sense dapat always on.
No, more on damage assessment na siya.
Para kasi we should parang yung to prevent the aftermath ng station.
Yeah. I can see where you are coming from. Kasi parang we will invest on this tapos hindi mo naman. We're also actually discussing that if kung kaya na ba talaga ng technology na gawin yung bagay. Much better.
All right. Sorry. We have to end the webinar already. So sorry, but if you have a question, you can just approach Engineer Joseph Sandro for that. But yeah, thank you, Engineer Sandro, again. Thank you all for your thoughtful questions, and thank you for sharing your expertise with